In this presentation, we are going to delve into the world of advanced regular expressions. Regular expressions are powerful tools for pattern matching and text manipulation. We'll explore extended features that allow for even more precise and complex text matching. Before we dive into the advanced features, let's do a quick review of some basic regular expression concepts. Core pattern elements include literals, which match exact characters, character classes such as B, C, which match any of the characters within the brackets, or negated classes, such as A, B, C, which match any character not listed. Quantifiers like asterisk, plus, question mark, and curly braces with N, M, control how many times a character or group is matched. Anchors like caret and dollar specify positions in the string, such as the beginning or end. Finally, the wildcard dot matches any single character. Here are some basic examples. To match an email pattern, we can use a regular expression that checks for alphanumeric characters, periods, underscores, percentages, pluses, and minuses before the @ symbol, followed by more alphanumeric characters, periods, and a top-level domain of at least 2 letters. To match a phone number, we can use a pattern that checks for 3 digits, followed by a hyphen, then another 3 digits, another hyphen, and finally 4 digits. And to match a URL, we can use a regular expression that looks for HTTP or HTTPS, followed by : then alphanumeric characters, hyphens, and periods, ending with a top-level domain. Now let's explore capture groups. Basic capture groups are created using parentheses. These groups allow you to capture the text matched by the pattern inside the parentheses, which can then be referenced later. For example, the regular expression open parenthesis apple pipe orange close parenthesis will capture either apple or orange. You can access these capture groups using numbered references, such as \1, \2, and so on. For instance, the regular expression \w plus space \1 will match repeated words like hello, hello. You can also create named capture groups using the syntax open parenthesis question mark, less than name greater than pattern close parenthesis. These named groups can be referenced with \k less than name greater than. Named capture groups improve readability in complex patterns. If you want to group parts of a pattern without capturing the matched text, you can use non-capturing groups. The syntax is open parenthesis question mark : pattern close parenthesis. These are useful for applying quantifiers to a group of characters or improving performance by avoiding unnecessary captures. Let's see capture groups in action with some examples. In this basic capture example, we extract date components. The regular expression open parenthesis \d curly braces 2 close parenthesis hyphen open parenthesis \d curly braces 2 close parenthesis hyphen open parenthesis \d curly braces 4 close parenthesis is used on the string date 05-23-2023. The captured groups are $1:05, which represents the day, $2:23, which represents the month, and $3:2023, which represents the year. This demonstrates how capture groups can extract specific parts of a string. Now let's look at a named capture example. The regular expression open parenthesis question mark less than day greater than \d curly braces 2 close parenthesis hyphen open parenthesis question mark less than month greater than \d curly braces 2 close parenthesis hyphen open parenthesis question mark less than year greater than \d curly braces 4 close parenthesis is used on the same date string, date 05-23-2023. This time the captured groups are named day:05, month:23, and year:2023. Using named capture groups makes it easier to understand and reference the captured data. Next, let's explore Lookahead and Lookbehind assertions. Positive Lookahead uses the syntax x open parenthesis question mark equals y close parenthesis. It matches x only if it is followed by y, but y is not part of the match. For example, \d plus open parenthesis question mark equals \south asterisk dollars close parenthesis will match numbers only if they are followed by white space and the word dollars. Negative lookahead uses the syntax x open parenthesis question, mark exclamation mark, y close parenthesis. It matches x only if it is not followed by y. For example, \b\w plus open parenthesis question mark exclamation mark \south plus, and close parenthesis will match words that are not followed by a space and the word and. Positive Lookbehind uses the syntax open parenthesis question mark, less than equals y close parenthesis x. It matches x only if it is preceded by y, but y is not part of the match. For example, open parenthesis question mark, less than equals $, close parenthesis \d plus will match numbers only if they are preceded by a $sign. Negative Lookbehind uses the syntax open parenthesis question mark, less than exclamation mark, y close parenthesis x. It matches x only if it is not preceded by y. For example, open parenthesis question mark less than exclamation mark unclose parenthesis \w plus able \b will match words ending with able that do not start with un. Let's look at some practical examples of lookaround assertions. For password validation, we can use lookaheads to ensure a password meets certain criteria. The regular expression open parenthesis question mark equals period asterisk open parenthesis a to z close parenthesis open parenthesis question mark equals period asterisk open parenthesis a to z close parenthesis open parenthesis question mark equals period asterisk \d close parenthesis open parenthesis question mark equals period asterisk open parenthesis bracket exclamation mark at $% caret ampersand asterisk bracket close parenthesis period curly braces 8 comma close parenthesis $ requires that the password has at least one uppercase letter, at least one lowercase letter, at least one digit, at least one special character, and is a minimum of 8 characters long. For price extraction, we can use Lookbehind to extract prices from a text. The regular expression open parenthesis question mark less than equals $, close parenthesis \d plus open parenthesis \period \d curly braces 2 close parenthesis question mark close parenthesis /g is used on the string items $15.99, $24, and $7.50. It matches 15.99, 24, and 7.50, but the $signs are not included in the matches. Now let's delve into advanced quantifiers and modifiers. Greedy quantifiers match as much as possible. Examples include period asterisk, period plus, and period open curly braces 2, 5 close curly braces. Lazy quantifiers, on the other hand, match as little as possible. Examples include period asterisk question mark, period plus question mark, and period open curly braces 2, 5 close curly braces question mark. Possessive quantifiers never give up characters once matched. This improves performance by preventing backtracking. Examples include period asterisk plus, period plus plus, and period open curly braces 2, 5 close curly braces plus. Regex flags or modifiers alter how the regular expression engine interprets the pattern. The I flag enables case-insensitive matching. The G flag enables global matching, finding all matches instead of just the first. The M flag enables multiline mode, where caret and $ match the start and end of each line. The S flag makes the dot match new lines as well. The U flag enables Unicode support. Atomic grouping uses the syntax open parenthesis question mark greater than pattern close parenthesis. Once the group matches, it's locked in, preventing backtracking within the group. This improves performance for complex patterns. Let's illustrate the difference between greedy and lazy matching with an example. In this example of greedy matching, we aim to extract HTML tags using the regular expression open angle bracket div close angle bracket period asterisk open angle bracket / div close angle bracket. When applied to the string open angle bracket div close angle bracket first open angle bracket / div close angle bracket space open angle bracket div close angle bracket second open angle bracket / div close angle bracket, The result is open angle bracket div close angle bracket first open angle bracket / div close angle bracket space open angle bracket div close angle bracket second open angle bracket / div close angle bracket. This is because the period asterisk takes as much as possible, matching everything between the first open angle bracket div close angle bracket and the last open angle bracket / div close angle bracket. Now let's look at lazy matching. Using the regular expression open angle bracket div close angle bracket period asterisk question mark open angle bracket / div close angle bracket /g on the same string, open angle bracket div close angle bracket first open angle bracket / div close angle bracket space open angle bracket div close angle bracket second open angle bracket / div close angle bracket. The result is an array containing open angle bracket div close angle bracket first open angle bracket / div close angle bracket and open angle bracket div close angle bracket second open angle bracket / div close angle bracket. This is because the period asterisk question mark takes as little as possible, matching each tag separately. Let's explore some advanced regular expression techniques. Recursive patterns are self-referencing patterns useful for nested structures. The syntax is open parenthesis question mark or close parenthesis or open parenthesis question mark 0 close parenthesis. An example for balanced parentheses is open parenthesis question mark or close parenthesis asterisk close parenthesis / close parenthesis. Conditional patterns provide if-then-else logic within a regular expression. The syntax is open parenthesis question mark open parenthesis condition close parenthesis then pipe else close parenthesis. For example, open parenthesis \d curly braces 3 close parenthesis question mark open parenthesis 1 close parenthesis \d curly braces 3 close parenthesis \d curly braces 4 close parenthesis pipe \d curly braces 7 close parenthesis dollar matches phone numbers with or without an area code. Subroutines reuse capture group patterns, reducing duplication in complex patterns and improving maintainability. The syntax is open parenthesis question mark less than name greater than ellipsis close parenthesis and open parenthesis question mark and name close parenthesis or numbered open parenthesis question mark 1 close parenthesis. PCRE specific features include Unicode properties like \p open curly brace script equals Greek close curly brace, callouts open parenthesis question mark capital C close parenthesis, backtracking control open parenthesis asterisk skip close parenthesis open parenthesis asterisk fail close parenthesis, and verbs open parenthesis asterisk except close parenthesis and open parenthesis asterisk commit close parenthesis. Let's wrap up with some best practices and resources. For performance, avoid nested quantifiers, use atomic groups when possible, anchor patterns with $, and \b, be specific with character classes, and test with large inputs. For readability, use named capture groups, break complex patterns into parts, comment your regular expressions with open parenthesis question mark # ellipsis close parenthesis, use free spacing mode with open parenthesis question mark x close parenthesis, and document edge cases. For security, validate input length before matching, set timeout limits for matching, avoid RDOS vulnerabilities, sanitize user-provided patterns, and test with malicious inputs. Here are some resources for further learning: Regex101.com, Regexer.com, the Regular Expressions Cookbook, and the PCRE documentation. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.